because the time of report is very short, I will pay attention only on the most important points of this problem. First of all, we decide that the most important strategical aspects of biogas technology there are. First of all, choice of suitable substrates for fermentation. That means energy efficiency of substrates, then availability for microbiome, and economical availability of substrates. The second problem is the technological parameters of process and methods for their optimization. It means, first of all, time detention, that means duration of fermentation, biodegradation coefficient, that means ratio of initial and end mass of waste, and biogas yield. The third problem is the treatment of secondary solid and liquid waste and obtaining suitable products, commercial products from this waste. And finally, problems in novel biotechnologies promotion. First of all, the change of substrate. On our opinion, the most spread in biogas technology substrates, such as different kinds of plants. That means, first of all, lignin cellulose as a chemical substance, and kettle mania are unsuitable substrates for the biogas fermentation. Why so? Because lignin consists of natural polymer with very resistant properties for biodegradation. And also one can see that lignin forms closed chambers that isolate the cellulose from bacteria. What about kettle mania? In kettle mania exists in high concentration and metabolites that highly suppress the cellulose fermentation. And it is obviously that mixing of plants, that means lignin cellulose, together with kettle mania lead to the strong suppression of fermentation. On our opinion, the optimal for the fermentation, the combination of multi-component food waste and methane tank sludge. Multi-component solid food waste have very certain positive properties. They consist of concentrated organic matter for the fermentation, then they're easy biodegradable substrates. Next positive feature, production in unlimited volumes. This waste constantly renewable substrate with zero cost because it is waste. And finally, profitability. That means localization of this waste in industrial regions or zones. About methane tank sludge. Sludge is unlimited source of diversified microbiomes that lead to the acceleration of fermentation any type of organic waste. Additional suitable substrates, there are sugar beet, fruit, vegetable waste, and sludge-aware tank also. About vegetable waste. First of all, high content of organic matter for fermentation, then properties, easy for fermentation, large volume of waste, zero cost of substrate, and finally profitability, that is means localization in industrial regions. But unfortunately, it has one negative feature. There are periodical renewable substrates. About sludge air tanks. It is concentrated protein substrate suitable for biogas fermentation, and simultaneously it is a source of diversified microbiomes that accelerates polymers degradation. So let's summarize. The optimal substrates, the main substrates, it is multi-component food waste together with sludge over air tanks and additional substrates, fruits, vegetable waste, and so on. Microbiomes, the more perspective, mixed sludge over air tank and methane tank, and the high top of this microbiome, the industrial dry granulated microbial preparates. Together, these properties, these substrates and microbiome have some certain advantages. About substrates, high carbon content that lead to high biogas yield, and microbiome high efficiency, that means fast digestion of a wide range of substrates. Simultaneously, there are two common advantages, such as unlimited, constantly renewable sources of substrates in microbiome and profitability, the zero cost. And at least it significantly increases the efficiency of biotechnologies. There are three most important technological parameters. It is time detention or time of fermentation, coefficient of degradation, and biogas yield. Unfortunately, nowadays in industrial technologies, this time detention is rather long, near certain days. The coefficient of waste degradation is rather small, not less than 10. And biogas yield is also small, only 30 or 40 cubic meters per ton. On our opinion, the main reason of low efficiency of biotechnologies is a phenomenon of stagnation. What does it mean? At the beginning of the 20th century, Sergei Kuznetsov investigated the metabolism in the bottom sediments in rivers and lakes. And this deposit sediments consisted of concentrated organic matter and simultaneously diversified microbiome. But nevertheless, the total biochemical activity of this microbiome was close to zero. And Kuznetsov discovered that the main reason of this absence of metabolism was the absence of mass exchange. It led to the accumulation of toxic end products and led to complete stagnation in microbiomes. That means the absence of metabolic activity. This phenomenon of stagnation in microbiomes is rather spread in natural ecosystem. Here you can see the mummy preservation in pet bags, box, and the age of this mummy more than 2,000 years. The factors of stagnation, first of all, as I told, the absence of mass exchange that lead to accumulation of organic acids in high concentration and stronger acidification and absence of microbial metabolism. Unfortunately, the stagnation also takes place in conventional bioreactors. Due to the high concentration of substrate, we obtain the high density and viscosity and inevitability, sedimentation due to the gravitation of these substrates. It leads to forming the so-called dead zones because the density of solid particles is very high. So on the surface of the particles synthesize in a great amount toxic exometabolites, and finally it leads to the stagnation in these substrates and low biogas efficiency. The solution of this problem is very simple. The first possible variant to increase the water content. It will lead to dissolving and to decrease the concentration of metabolites inside the liquid media and to respectively to increase the effectiveness of biotechnology. Instead of complicated and expensive construction with mechanical mixing, we suggest novel type of bioreactors with a very simple design. Only cheap and effective pump provides the effective mass exchange. And here you can see two types of devices that we successfully provide for the biogas fermentation. And also it is possible to obtain the simplest design of reactors due to the direct flow of the liquid inside of this liner bioreactor. We obtain permanent dilution, evacuation of toxic exometabolites. And it is obviously that in this bioreactor no necessity of any mechanical devices for mixing. And the case is synthesized after purification can be, after biofermentation can be successfully purified in air test. It is also our design due to the phenomenon of special succession in this process. Due to the special succession, we obtain the decrease of organic content calculated on total carbon in more than 800 times, from 21,000 ppm of total carbon content to 25 ppm. Due to the special succession, excuse me, first of all, microorganisms consume the soluble organic compounds. Then these bacteria serve as a food source for infusoria, infusoria as a food source for rhizosphere, and so on. And fishes close this food chain. So the end result, completely purified water and heap of fish. Another type of bioreactor, circular mass exchange. It is suitable for degradation with gas obtaining for the very large particles of solid organic waste. Due to the permanent vertical flow of liquid, we obtain evacuation of toxic metabolites that lead to acceleration of the process, and after purification of this leachate in air tank, this phase return to the column. Due to this type of fermentation, only during 7 days we obtain the mass decrease in 16 times, and the absence of stagnation was distinguished due to the active mass exchange, direct flow of leachate, and purification of leachate in air tank. So you can see the picture of a decrease of mass of the particles. And finally, the closed cycle of combined hydrogen methane fermentation gives a positive, binary positive effect, environmental effect, and also the energy effect. Because only at 14 days we obtain the waste degradation in 20 times. Simultaneously, we obtain 27 liters of molecular hydrogen, 12 liters of methane, and additionally from each liters of leachate, we obtain 1 liter of methane. About the environmental effect, we obtain the decrease of soluble content of soluble compounds in 100 times, from 2000 ppm down to the 20 ppm. So we can summarize that we obtain 6 industrial technological parameters that give the possibility to improve in comparison with industry, time detention improving 12 times, degradation index in 6 times, and biogas yield in 3 times. Also, we can obtain a number of useful products due to the fermentation. First of all, molecular hydrogen, then solid fuel as non-fermented resides organic waste, and biofertilizer after the fermentation, additional fermentation of non-dry digested, non-digested waste. Also, we can purify the toxic leachate with containing almost purified water that consists of only 20 ppm of total carbon. Recently, Ursula von der Leyen suggests a burial of carbon dioxide on the depths of 2.5 kilometers. We would like to suggest a more simple decision for decarbonization. The production of building materials or chemical or technical materials due to the reaction of carbon dioxide with the industrial waste. So we can obtain the building materials and technical sodium carbonate. Problems in novel biotechnology promotion. The promotion consists of several steps. Novel idea transformed to scientific investigation, then step by step to final technology that needs the maximum sales of standard, this installation, and the requirement of technological constancy. That's why it is impossible to improve this technology by the novel ideas. But on our opinion, it is possible to change very simple, to make very simple steps to change the technology in the side of it optimization. For example, increase water content. We invite to the collaboration, and thank you for your attention.